Hey, we're in Module 18. And in this section, we're going to have a look at both IoT and OT hacking. Both of these are highly growing areas of manufacturing and industry in ways that may not be completely obvious right now. But we'll talk about some of those and why this is so important. But first, let's get an overview about what we're going to talk about in this upcoming section. So here in module number 18, we're going to explore two major concepts of small devices that communicate with each other over networks, including on the IoT side. We're going to be looking at those concepts, hacking methodology. We're going to be looking at some countermeasures. And then on the OT side, same thing, right? So we're looking at attacks, methodology, and countermeasures. And so we're going to start off with the Great Divide. So we're going to start with IoT hacking. IoT is an amazing technology. We'll talk about the difference between IoT and OT technology as we move forward. Objective number one is to explain IoT concepts and attacks. So let's start with IoT concepts. So what is IoT? Well, IoT stands for the Internet of Things. Inanimate matter is waking up. It used to be that you just had a refrigerator. Now your refrigerator tells you when you have run out of milk or something like that. You used to have just an inanimate coffee cup, but now your coffee cup says, hey, your coffee has dropped below drinking temperature. You used to have just a car. You would start it. It was hard to start in the wintertime, but now your car will talk to you and measure things and so on. And it's going even more than that. There is our medical devices now that will report. Like for instance, you can get a little implantable blood glucose monitor, and there's an app on your phone. It tells you when you have glucose spikes, and monitors it over years. There are pacemakers. There are other and increasing number of medical devices. But if you look over here on this slide, you'll see smartwatches. Like I was showing you, might see my pulse right now is 98. Well, I got 10 beats faster. TVs, manufacturing. I was already talking about healthcare. This is going to be exploding soon also. Home devices. And the reason I say this, by the way, is because there's been federal approval for a device that is one of the glucose monitor devices that is over the counter now. So you don't actually have to get a prescription. And I think that's going to happen with a lot of other devices soon also. So monitoring energy. But overall, these IoT devices, they are small, a lot of them. Some of them are larger. What they're going to do is they're going to send data to an IoT gateway. This is going to be like your edge network router. And then they're going to go to this little planet right here, signifying the internet. And then what's going to happen is in the cloud, we're going to be talking about the cloud really soon, we're going to have all the back-end logic and information storage and so on. But then on your tablet or on your phone, you have the app that you can control. Right now, most of you, well, a lot of you at the very least, can open up an app and see stuff about your house, like your front yard, your cameras, doorbell, your garage, and stuff like that, because you have IoT devices. But this is generally how it works. All right, so the architecture, if we look over here, IoT starts right here at the bottom, at the edge, where you have those devices, those sensors. Then we have protocols. We're going to look at some of those. Connecting out to endpoints, device management, and then all the way up to that application layer where we can control and manipulate and understand what's going on with that device. But let's start with a look at some of these protocols. This is one of the problems with IoT and OT. So OT is going to be the industrial, like SCADA, like everything from electricity to chemical plants to sewage processing, all the stuff that makes a city and a national infrastructure run, the traffic lights, etc. Whereas IoT is going to be your doorbells and medical sensors and so on. And both of them have a variety of protocols. So there are a lot of you, if you're taking this class, you're already pretty good at a few things in terms of IT. But if someone gives you a device and you find out that it's, let's say that it's running on Zigbee through QUIC using MQTT and Riot over co-op, right? Although that combination wouldn't work. But my point is that there are a lot of different protocols that most IT networking people aren't that familiar with. Now, one thing that this has going for it is a lot of these make use of a TCP/IP and are shipped and make use of TCP/IP to connect them from one point to another, but not all of them do. All right, so the top threats: weak, guessable, hard-coded passwords, insecure networking ecosystem, updating, outdated components, insufficient privacy protection, data transfer that's messed up. It doesn't say messed up on number 7, but that's what it means. Lack of device management. So I can't take all my devices and put them under one management like what we're doing with mobile devices with MDM. Insecure default settings. Lack of physical hardening. Wow, that's a lot. But there's worse. I mean, look at the surface area of attack. We have 15 different areas that you, as an attacker, can scan, that you can discover, and then you can crack it open and get information out of that device. And it's not getting better. It's not getting better because there are manufacturers popping up all over the world. You might get a device. Let's say you're looking for a doorbell for your house. So you go to Amazon, you type in video doorbell, and right at the top of the list, what brand is going to pop up? You tell me. Yeah, you're right. It's the Ring doorbell. Oh, it's Amazon you're searching. And then the next one below that, you see all these doorbells. They look a little bit expensive. So you invert it and say sort by low price. And you go through a page or two until you find a doorbell. And the Ring doorbell costs $90. I'm just making that up. It probably costs less. But this doorbell you found costs $9.95. Wow, that's great. I could get one for my front door and my back door. But when you look at it, where was it manufactured? So there are all these innovative companies all over the world. Let's say somebody in a small city outside of Jakarta in a suburb popped up a startup and they made the doorbell. Or somebody in a small suburb of Shenzhen, China popped up a startup and they made the doorbell. And whoever it is, what if they didn't have any security standards? They were just making it as cheap as possible, because in the Western world, cheap often sells. And therefore, the data storage is messed up. The firmware doesn't work. The web device interface is not good, and so on. An example, a friend of mine wanted a video, one of those little, it's like a picture frame, but you can import pictures into it and they rotate. Those are pretty cool. Well, she got a cheap one and she was having trouble with it. So she brought it over to the house and she showed me the app interface for it. And she told me, we demonstrated that you could not log in to the app. So what happens is you download the app and then it says, in order to use this app, you have to fill out this form that asks for personal data. And then you fill out the form and then you submit it and it just disappears and the app still doesn't run. And there are other issues with the device. And so I told her, this is messed up. It has some of these things, right? Some of these attack surface area issues. And so she sent it back. She got a more expensive one that had a good app, well managed, and it worked just fine. Okay, so we have other vulnerabilities. We have username enumeration. So I might be able to find usernames on that app, just interacting with it, get those maybe weak passwords, like 1, 2, 3, 4, 5, 6. Some of these passwords, by the way, on some of these devices, they're hard coded. You can't even delete it. Maybe there's no way to lock out the account. So an attacker has all the time in the world. They have 238 days to attack your device, and it's unencrypted. There's no 2FA, poorly implemented encryption. Maybe it's a hashing scheme and not an actual encryption scheme. Or maybe updates are not encrypted. Or maybe you can see the location, or it's vulnerable to denial of service attacks. Or maybe the storage media is removable, no manual update mechanism, missing update mechanism. Maybe the firmware version you can't even find when the last version came up with. And then we have firmware storage and extraction issues. And speaking of firmware, so this is a scenario that I often talk about when I teach this. So let's say that my boss says, Kevin, see this little device? We're going to buy 500 of them. I want you to test it and make sure it's secure on our network. And I say, thank you, boss, let me have that. So I take it to the workbench, and I find it has a lot of problems like this. And one of the things I find when I decompose the firmware is that the firmware is a wreck. So I'm thinking, maybe I can redeem this device if there is an update to the firmware. So the device is called CEH123 IoT. So I go online and I look for CEH123 IoT firmware. Sure enough, right at the top of the search results, there is a place where I could download a secure firmware update for this device. And when I click on the link, my browser and antivirus go crazy. Alert, this is a problem. Don't go to this site. It's a corrupt site. What happened? Well, it's not just I who figured out there were firmware issues with the device. An attacker figured out there were firmware issues with the device. So the attacker's like, you know what? People are going to want to fix this firmware. So I'm going to make a illicit update that'll give me a backdoor into that device, and then I'm going to advertise it and make it get to the top of the Google search results so somebody like me can click on it. That kind of stuff happens. So obtaining console access so someone can get to the console. Google Dorks is a great way to get to all kinds of IoT consoles. And then third-party components that are also not secure. Huge vulnerabilities for IoT. So that leads to a variety of threats with IoT, from DDoS to rolling code and Blueborn and Sybil and forged multiple identities and fault injection and network pivoting, blah, blah, blah. I mean, look at it. It's huge. Well, hey, you know what? Let's take a look at these. Let's start with a DOS attack. One of the biggest types of attacks that we see used, that IoT devices are used in, is they become botnets. And there can be hundreds of thousands of them. And they're used to run attacks. And we also have HVAC. One of the things that I had the privilege of doing, and I'll talk about this more in the OT side of things, was managing HVAC systems. And this is an area that is low-hanging fruit for OT and IoT. And this attacker is just looking for devices on the network. Look at this. They're using Shodan. Yet I talked about Shodan before at the beginning of class. And they're using that to identify systems that are hackable, and then they're hacking them. Over here, we have rolling code attack. So you have a key fob. You have a bag of groceries, and you're walking out of the store, and you walk over to your car, and you click on the unlock button. Nothing happens. Oh, that's weird. So you click on it again, and it unlocks. You put your groceries, it's just nothing but peanut butter and fluff and some bread. That's all that's in your groceries. But anyway, you take those groceries and you drive home, and you take that peanut butter and fluff. It's just your supply for dinner. You know, have to have those fluffernutters. And you take that and start putting it away. And meanwhile, you hear your car start. You run to the window and it's driving away. Somebody just did a rolling code attack. We'll talk about one of the tools that's used. And the first time you hit that button, they were able to take that code, and then later on they're able to replay it essentially. RF crack, we'll look at that in a little while, which is one of the best rolling code attack tools out there. I already talked about a Blueborn attack. I was explaining it while we are talking about another type of Bluetooth attack. And you can see here, again, we're going through a Bluetooth-enabled printer like I was talking about before. Jamming attack, we've already talked about that. Flooding the airways, not airways, but the radio signal ways with a bunch of stuff at the same frequency. Now we have a few other types of attacks to talk about. This is a smart grid or industrial device type of attack. So what's going to happen here is the attacker is going to send a nice little email. It's going to be friendly, or it might be urgent. Whatever it is, for workers of an organization, this email has a malicious file attack. And then, of course, the user in this company is running unpatched human 1.0. Uh-oh. So what they're going to do is download the file, and then it's going to install a backdoor. The attacker now has a backdoor, and now they can get through the local network through the HVAC system. And by the way, this is why when we talk about OT, we'll see it's so important to separate these systems. And now they can disable power supplies or turn stuff off, all the whatever, right? So that's a lot of potential attack capability. But one of the things that these attackers are doing now, when we get into OT, we'll see this, they're lying in wait. They have the path all the way through. They may even have a script that periodically checks to make sure they have maintained access. And what they're doing is they're waiting until they get a command from their government or their organization. It could be anything from a regular just government to a regime to a terrorist organization. And when they get the command, boom, they unleash it on everything. So that is actually happening right now, where they are just lying in wait with their attack already ready and good to go. Another area that I find fascinating is SDR. Have you heard of software-defined radio? I'm sure some of you have. It's not just IoT. It's a way of taking usually you need like a little USB dongle, and it gives you access to the entire RF frequency. We'll look at some tools that are useful for RF hacking. But yeah, this is software-defined radio, and it gives you more spectrum than just Wi-Fi or whatever. It allows you to do things like replay attacks, analyze cryptography, and do cryptanalysis attack, listen in on what's going on. One of the cool things is with a SDR dongle and some good antennas, you can do all kinds of monitoring. Like one thing that's really fun is all the aircraft. And by the way, drones of a certain class and that fly a certain height have to have a little tag, and you can actually see what airplanes are flying over and around you just with SDR. And there's so many other things you can do. If any of you, are you a ham? You have a ham radio? If you study ham radio, they take you into studying all the frequencies and so on of radio. And this kind of dovetails a little bit into that too. Very interesting stuff. All right, so identifying local IT devices. So what we're going to do is we're going to do some scanning. We're going to find these devices. We're going to send some TCP SYNs in. We're going to find where they are, and we're going to then maybe do some DNS rebinding, redirect those devices through the attacker's machine. That's a possibility. We can even do things like fault injection attacks. All right, so you've finished the class. You've attained your certified ethical hacker certification, and you show it to your boss. And your boss says, okay, wait, don't go anywhere. And he calls in the director of security and the CEO. They're like, we have a special project for you if you're interested. We want you to infiltrate the competition. And when you get into the competition, I want you to get a job over there. And I want you to go to one of their data center stacks and put this flash drive in this type of data center server. And in just 4 seconds, it'll collect the information we need so we can get ahead of them. So being unscrupulous, you decide that you will play along. And so you go to the other organization and you've made your way into their data center. But there are too many people in the data center, and if they see you opening the rack and putting in the flash drive, you're going to be in big trouble. So what you do is you need to clear the data center. So you reach into your pocket and pull out your handy dandy lighter. One flick, second, third, the flame comes up. You move it to a sensor, and the data center senses that there is fire. The alarm goes off, whoop, whoop, and everybody in the data center clears out. And it says 15 seconds, right? It keeps on counting down. So meanwhile, everybody clears out. You go over to the rack, you plug in your flash drive, and just as you unplug it and leave out the back exit, halon dumps over everything. All right, that's kind of dramatic, but that's to illustrate a fault injection attack, right? You put fire on that sensor, and it thought there was a fire in the data center. Now, obviously, that is a fallacious scenario in a lot of different ways, but that's just to illustrate the point that you can make a sensor believe something. It's too hot. It's too cold. You can do BBI and EMFI. EMFI is electromagnetic fault injection. BBI is body bias. And so what you're going to do is you're going to inject some type of fault into an electromagnetic device, like lasers. So like you put that light into the device, and there's also frequency and voltage tampering where you can modify the power. Even like unplugging something can set a certain condition on a device and cause an attack. There are also power and clock resetting glitches that you can do by setting the clock, like for instance, getting rid of daylight savings time or moving it forward or ahead. Oh, this happened to me. I was a bad employee once. I was in college at the time, and I would come back from college to work for a defense contractor. And this was a long time ago. So I'm like totally old, okay? So this was in the 80s, and the defense contractor had a VAX 11780 or 11785. So you look those up, you'll see how old that is. And when I had come back, I logged in my account. They brought it back online, and sure enough, there was a new version of the operating system. And I was like, wow, that's cool. So I typed in commands to see the command list, and I was like looking, you know how you type in a command to get help? And I kept on trying commands, and I found some really interesting commands. And finally, there's this one that was called something like set time. Yeah, that's what it's called, set time. So I did set time help, and nothing happened. I actually got an error. So I just typed in set time, and nothing happened. So I typed in set time again, and nothing happened. It's like, oh, well, I guess I don't know what that one does. And I kept on going through, and it looked like a really cool update to the operating system. Until my boss, his name was Carl. He's since passed away, but he was a really fun guy. But he wasn't at the time. A couple days later, I got called into the office, and Carl's face was red. And he said, he got himself under control. And he said, Kevin, did you do a set time? I'm like, set time? What's that? I've never. Then my memory from a couple days ago came back to me, and I said, yeah, what was that? And it turned out one of my colleagues, Kimberly, she had written a script to roll back the time for daylight savings time. And what I had done was roll back the time 2 hours, because I ran the set time twice. So everybody that was connected to that system that was being billed for specific contracts got billed an hour of compute for everybody who was connected. And I felt so bad that, because what's going to happen now is my friends in the IT department are going to have to go through all the accounting and back out all of those charges. I thought they were going to be mad at me, but I got yelled at. So when I went back into the office, they were laughing at me. So I didn't get in trouble with my colleagues, just with the boss. But that's what happened, is I did a glitch on the timing of that computer with that set time. So anyway, be careful with set times when you go back to your VAX 11780. Temperature attacks, where you can change the temperature, those are all glitching attacks. Other IoT attacks. So there is an example. This happened recently to prove how this works. So this guy got a bunch of phones, like I think it was 15 or 20 phones. They're all running Waze. Do you use Waze or do you use like the regular Google Maps or whatever? I use Waze. Anyway, he got Waze and he got them all turned on. And then he walked slowly down a big boulevard with a wagon full of phones. And so Waze reported that this 45-mile-per-hour street, all these cars were going 3 miles per hour, and it marked it as a traffic jam. So that's what Sybil is. So if you look this up and you can do a search in DuckDuckGo or Google, Sybil movie. Sybil movie. So there's an old movie from, I think it's the late 70s or early 80s, about a woman with multiple personalities. And it's supposed to be like a horror movie, but that's what this is about, multiple forged identities. There are exploit kits for IoT. IoT can be used as man-in-the-middle or replay like we saw sort of with rolling code, and we'll see also replay when we get into OT. Forged malicious device where you can put in your own IoT device into the network and hack from there. Side channel attacks where you can attack like the encryption or something from a side channel, and then ransomware where you can say, you know what, I've got your IoT network, pay me some Dogecoin or some Ethereum or you'll never get it back. So there's IoT malware that's all over the place. This is very interesting. One of the things you need to keep in mind with IoT and OT malware is there's usually not a lot of space on the device. So one of the constant themes in this type of malware is they kick out all the other malware. Hey, only I can be on this device. But this one is called KMSDBot. KMSDBot or sometimes it's called KMSDX. It has new features. Hey, it's brand new. Like telnet scanning, authentication. What it tries to do is expand its reach to other IoT devices by exploiting SSH ports, default credentials, default passwords. A lot of these, this is not the only one that does that, but what they'll do is they'll bring with them a giant list of default usernames and passwords for IoT devices and then try them. It does a huge range of CPU architectures and devices. It's very adaptable. It makes use, again, of those defaults. And so it's giving you some of the default credentials stored right here and using Telnet over here. So yeah, this is definitely one of the IoT malwares you have to look out for. Okay, so we are in objective 2. So you've decided you want to hack IoT. So let's have a look at the hacking methodology. When we start with the hacking methodology, one of the crazy cool tools is Shodan. And Shodan gives you a lot of capability to find by IP address search, by host name, ISP, device location, banner information. They're giving you an example here for webcam XP. That, by the way, that's a good Google Dork search also. Another thing that you'll see is sometimes they'll give you a little snapshots of what it already found. So this is a very good tool. Sometimes Census is compared with Shodan. It's a good one. There are other things here like FCC ID search. What this does is it gives you FCC information on the device. It's a pretty good database. Then multi-ping will go and ping all of your IoT devices in your network. So collection of very good IoT tools. And then we can gather information using sniffing. Nmap, very good for that. Airmon, very good for that. So in this case, we're going to do port 8081, 8080, and 8081. Target address, we can use ifconfig, right? So remember, though, I showed you the IP link commands that you can use if you want instead of ifconfig. Airmon, NG, and so on. We can characterize the network. And there are many others down here at the bottom that are very good for finding those IoT devices through protocols. IoT Seeker is yet another good tool to find devices. This one we're looking for default credentials on the device, looking for those factory credentials. If we can find that, then the device is completely hackable. Next thing we have is another cool little device called GenZi. Something like Gen Z, but a little bit different, right? And what this does is it's a nice little security tool, and you can scan IoT dashboards looking for a variety of devices, HMIs, we'll talk about that in the next section, wireless routers, regular devices, looking for vulnerabilities and others. And then there's B-Storm, IoT exploit, and other things that are very good for scanning for IoT devices. And then the one I mentioned a little bit earlier for a rolling code attack. When somebody hits that button on their key fob is RF crack. If you've never used RF crack, it's worth a try. Don't hack your neighbor's car. Only hack your own car. And if it's vulnerable to a rolling code attack, which a lot of modern key fobs are not, but if it's vulnerable to a rolling code attack, you can run the RF crack Python, and there are various parameters that you can use to run your rolling code attack. And then we also have protocols for IoT devices, in this case, Zigbee. So there is a nice little tool, a device called Open Sniffer. Check it out right here. This is cool. So you can get yourself one of these, and you can what it does is it'll continuously emit packets and create a DDoS on the device. You can even do a little bit of crafting, send user-defined frames, replay captured frames, and do a replay attack. Not quite as good maybe as RF crack, but you could definitely do replay with Open Sniffer. And then this one has been around for a while. It is a very cool tool for Zigbee, LoRa. You could do blue-borne attacks with it. You can do fuzzing with it. You can do jamming with it. Airborne attacks. It has a good frequency range between 1 megahertz to 6 gigahertz. And it's a transceiver, half duplex, GSM to Z-Wave. This is just to look at the UI for it. And so you can find FC database information, use it in conjunction with your RTL SDR. It's a little dongle that gives you RF capabilities on your device. So HackRF1, very nice tool. Other things you can do at the Wi-Fi level, not the Wi-Fi, but this is at the hardware level for IoT. And this is not just IoT, by the way. Right? So what we're doing in this case is looking at COM buses and interfaces. So for instance, you can open up a device, and in that device, it'll have a little PCB. A PCB is a printed circuit board. And that PCB will have logic gates on it, CPUs, capacitors, resistors, and all kinds of other electronic components. Having a little bit of facility in electronics is very helpful for the ethical hacker. So you can use tools like the Diva or Bus Auditor or other things. This is the Bus Auditor right here. So you see these things right here? These are little pin connectors that you put on the pinouts on boards, and so that you can get UART or IC2 information out of these boards and change them around. Let me just give you let me give you an overview of how this can work in a very simplistic methodology. So let's say that you need to break into a desktop computer, and the desktop computer has an operating system that's locked down. And so you know that you can get some control over this desktop computer if you can get to the CMOS or whatever that boot controller is, right? So what you're going to do is you're going to hit F2 or escape or whatever it is, and you're going to get to that first screen, and it says password required. Oh my goodness. So in order to get into this low-level system, it requires a password. What am I going to do? Well, now that I have my hands on the system, what I can do to get into that UFI, to get into that CMOS, to get into that low-level OS is I'm going to open up the motherboard, and I'm going to find, as you see right here, the chip. and there are several different ways to do this. I can reset that chip that has that firmware on it so that it goes back to factory default. And then when I reboot the system, I now have access to the BIOS, the CMOS, the UEFI, or whatever it is that's at that low level before handing it over to software, firmware, and stuff like that. So that can allow me to gain privileged root access by using these lead clips or test clips, or pulling little clips that tie certain circuits together, etc. So we can interrupt a boot process, and then from there we can potentially gain root access. There are so many things you can do, especially on systems like Linux systems, when you can override that boot process. One of the things I've said repeatedly in this class, if I can touch it, I own it. So if this is a PC, I get my hands on it, I can open it up, I can NAND glitch, I can interface with the motherboard, I can do all kinds of things to own that device. I don't care if it's a desktop, a laptop, I don't care if it's a router or a switch. If you can touch it, you own it. Another one is cameras. Sometimes I'm freaked out at the types of things that you can find with open cameras on the internet. So back in the old days, if you bought a baby monitor, it was just like a little teeny walkie-talkie version, and you could hear, you know, scratchy sounding audio, and you could, if your baby woke up, you could hear that, but it was barely able to be heard over the scratchy analog audio. These days, you have an internet-connected device in the baby's bedroom that has clear video and clear audio watching over that little baby. And so people turn on cameras because the person who set it up didn't do a good job securing it, or maybe they unsecured it so other people can access it. I don't know, but all kinds of cameras are on the internet. Camover is a camera exploitation tool that you can use to discover the admin password of the camera. You can see them running just to help for Camover and Parrot security. And so there are commands that you can use in Camover to get information. This command will exploit a single camera. This is the -A and a -T to exploit cameras that are connected to the internet using Shodan. So Camover is pretty cool. Telnet. Yes, there is still a huge amount of Telnet out there. And if you go to Shodan, you can find it. If you go to Google Docs, you can find it. If you go to Census, you can find it. And sure enough, it's open. Oh, one of the things that you want to look out for on Shodan, this is very interesting. Periodically, you'll do a Shodan search to look for IoT devices and or cameras or whatever. And you'll find one, and see right here where it says open ports? This panel will be like all the way down to here with all the open ports. And then there'll be all kinds of hackable protocols. And then up in the upper left-hand corner, it'll tell you this is probably a honeypot. Yes, I think so. So yeah, sometimes you'll find honeypots on Shodan. So, but either way, you can find all kinds of devices still that are not honeypots that are running Telnet. And then there is firmware. And you can take the device that you have on the bench or to which you have access, and you can deconstruct the firmware, find vulnerabilities in the firmware, and or re-upload your own version of that firmware so you can have more control over the device. You can reverse engineer it. They're showing you some of the steps here where you get the firmware first of all, analyze it, that little bin file, run binwalk to look and extract information from it. Then we're going to mount the file system, analyze it, and then we can emulate it. We can run it, the new updates that we put into it. There are also other tools. By the way, there are so many very awesome tools that are, hey, this is my slide adventure. They're about this size. This one is very small like that also. There are many of them. You've probably heard of a lot of them that are used for hacking various things. This is just one of them, Cat Sniffer. to monitor IoT traffic, gather information, Killer Bee, Wiz exploit, and many others. And I am sure that you could name a series of very cool hacker tools that either you currently have or you would like to purchase. Objective number 3, countermeasures for IoT. Let's have a look. So for countermeasures, you want to defend against people hacking your IoT device. Now, first thing I want to say about this is buy better. Buy better. Purchase better. In other words, before you purchase IoT devices, make sure that they're securable, manageable, that they have the ability to do good authentication, authorization, accounting, where you can actually pull data from them, from their logs, and they have good encryption, and they can allow you to change the defaults. So that's what we're talking about. So stuff like disabling guest and demo, making sure we use the lockout for logins, strong authentication, locate that controls that you want to make sure you know where they are. IDS is an IPS, end encryption with a PKI. Hey, maybe even using VPN. That might be a good idea to encrypt the communication to and from that device. Deploy security as a unified system across your IoT devices. Allow only trusted IP addresses to access the device from the internet. Otherwise, it might be somebody who wants to exploit that camera or whatever. No telnet on your IoT device. UPnP. Oh, let's stop here. Remember how I was telling you in wireless? I don't know, that module was so long ago. But remember I was telling you in wireless that you want to examine your edge device to see what technologies that it has on it. This is one of them that you want to look for. It's UPnP. UPnP is universal plug and play, and it also can lead to a lot of hacks. It's mainly used for facilitating internet-based gaming. If you're not using it, get rid of it. It leads to attacks. That's why disable that on routers, right? Also, physical tampering. So if you have a series of devices that somebody might be able to walk up to that device and steal it or replace it, then maybe lock it down so that you know, or at least tamper evident, if not tamper proof, right? Patch vulnerabilities, firmware, monitor. This port is very important for various types of malware, etc., which is 48101 for infected devices on the IoT network. So some general guidelines. Are you a manufacturer? If you're not, maybe you should be. That might be a good business to go into. But no matter what, if you are, or if you are working with an IoT manufacturer, then make sure that you have encryption available both for data at rest and data in flight for that device, like SSL and TLS. Strong passwords should be available for that device. Make sure the device can participate in a what? What is that? WOT, Web of Trust, or Chain of Trust. We'll see that more when we get into the last module. Account lockout, making sure the device can be locked down to prevent various types of attacks. Check it for unused tools. Whitelist the items that should be there, blacklist the most common forms of attacks, and then use a secure boot chain, verifying all your software, firmware, and hardware for booting. Next thing we look at is the OWASP top 10 IoT vulnerabilities and solutions. And we see this repeated over and over and over again. What is it that we see repeated over and over again? Weak, guessable, hard-coded passwords, right? So we want to use maybe APM, automated password management, strong complex passwords, no hard-coded passwords. And then we already talked about UPnP and secure services, the ecosystem itself that it plays in, maybe a lack of a secure update mechanism. So all of these, we've kind of discovered them. OWASP doesn't discover them themselves. They look at what's happening around the industry. So that's why we see some of these device management. So most of these we've already talked about a little bit, but just keep in mind that there are solutions for every single one of these vulnerable areas. So hardware best practices. Limit entry points. We already talked about tamper protection, secure booting, maintaining a proper interface management. So a lot of these we've looked at a little bit, but authentication, ubiquitous encryption, ubiquitous authentication. We want good logging, anti-malware protection. That's can be hard, but there is anti-malware, and very lightweight encryption too for IoT and OT devices. Isolating it from regular supply units. We're going to talk more about that when we get into OT. And then root on trust mechanisms. So there are a lot of things that we can do to defend them. And then at the application level, code signing, secure boot, secure API endpoints. So some of these things we already saw when we're talking about application security, but we also need firmware security and updates. So IoT device management, probably one of the best IoT device management solutions is Azure. Azure has a very great Azure IoT, should be on this list. CCAT-IO, Artemis, Oracle, AWS, there are many of them that do very good at managing IoT. This brings us to objective number 4. We're going to explain some OT concepts and attacks. Let's have a look. So with OT, it is similar to IoT in that it's small devices that communicate through networks and through the internet. But for OT, operational technology, it's a little bit different. If you've ever had the opportunity to be in a large industrial plant, like an oil processing plant or concrete processing plant, we have some of those around here, or maybe a giant factory that produces automobiles or creates some other type of automated capability. Think of a factory that creates baked goods like Twinkies or something like that. Right? These are large plants, industrial plants, also municipalities, energy generation, nuclear power generation, oil, gas, all of that is part of OT. And it's designed to find and sense issues in the plant. And before we talk about some of what OT is in terms of these terminology that we see right here. Another thing that you want to understand about OT that's a lot different from IoT, and really, frankly, a lot different than all the technologies that we talk about in this class. All of the technologies we talk about in this class, when we're talking about countermeasures and defense, what we're trying to do is defend the data, the customer's data, the credit card data, items like that, all of it. But for OT, it's not the data that we are defending, nor is it the data that most attackers are attacking. You know what it is? It's the industrial plant itself. Imagine this. There is an oil refinery, and in the oil refinery, crude oil is turned into a multitude of products. A lot of this involves using high pressure vessels in high heat. They're high heat and high pressure vessels, like for instance, for the production of petroleum distillate or something like that. And let's say that there is a high pressure vessel, very hot pressured, highly flammable gas, and it is maintained at a certain temperature pressure mix. And if that changes at all, it could be catastrophic. And let's say that an attacker attacks some of the PLCs, or maybe makes their way through an HMI into the plant and stops the sensors that sense temperature and pressure from reporting correctly. And then that high pressure vessel explodes. When it does so, it'll send a huge mist of gases into the air, creating a fuel-air mix. And then when there's a spark, there's what we call a Blevy explosion. Some of these can be the size of a small nuclear weapon going off. It's horrible. Worse than that, in some cases, is if a vessel that is full of high pressure gas explodes, and especially if that gas is heavier than air, it can creep through the entire area, killing everybody that breathes it. So what we're talking about for OT, SCADA, a lot of the time is life and limb. Imagine if everybody that is heating or cooling their houses loses that. You could have people that die of heat exhaustion or freeze to death. I mean, we're talking about lives here with OT. So it's a little bit different in what we're defending with OT, SCADA, with all these control systems, etc. I mean, imagine what has happened in plants that have lost that control, like in Fukushima or in other nuclear power plants. 3 Mile Island, we almost got there, but there wasn't actually more than the amount of radiation released for an X-ray, and nobody was injured. But for other ones, like in Russia and in Japan, those have been pretty big releases of radiation. So if you have an industrial issue, you can have real-world human consequences. So let's dig in to what these systems are. First of all, we have ICS over here. These are industrial control systems, and those work, as you can see, we have SCADA overall, and then we have these industrial control systems and these distributed control systems that are all interfaced with HMIs. HMI is a human machine interface. A lot of this can be part of SCADA, which is supervisory control and data acquisition. And they make use of units like PLCs, programmable logic controllers, and RTUs, remote terminal units, so that you can remotely access and control things on these systems. So you have a variety of control systems put together to take this industrial layout. Could be a municipal power system, or it could be a water reclamation system, or it could be a distributed energy wind farm, or whatever. That is what we're talking about with this. There's a convergence between the two. On the left here we have OT, on the right we have IoT, and with OT we have some of these systems that we're just talking about, including mechanical devices, which you really don't have that much when we're talking about IT. So IT is mainly cloud, internet networks, Wi-Fi, database, application programming, etc. So what we see here with IIoT, which is the IT-OT convergence, is that we're entering Industry 4.0. You might want to have a look. If you do a little search on your one of your tabs and look up Industry 4.0, you'll see that we are now in an era where we have advanced robotics. In fact, did you know that we are in the extreme beginnings of a robot revolution? If you want to see what I'm talking about, there is a movie called I, Robot. And if you go to YouTube and type in I, Robot intro or introduction, they'll show you the introductory sequence. And Will Smith is the actor in this one. And as he's going through the street, there are human-shaped robots all over the place, delivering things, carrying things for people, moving all over the place. And that is the era for which we're headed, with billions of human-shaped robots doing things, and they're all OT devices, IoT devices, with a merging of that in LLMs, and maybe what we might call Industry 5.0 as that is coming up. We have a huge number of startups that are actually being fairly successful, and this is only made possible because of the advent of AI and large language models. So now we see that there's a convergence of IT, and let's put another circle over here, AI and OT. So actually we have a lot of converging going on, and so it's very important to know how to defend it And in order to know how to defend it, we need to know how it's put together. So when you're dealing with OT, one of the things that you want to keep in mind is the separation of the environments. There's this thing called the Purdue Enterprise Reference Model. The Purdue model, or PERA, is a very good way to set up these systems. So if you are asked, which is very possible if you become a pen tester, or if people know of your ethical hacking skills, they may ask you to look at an industrial plant. And what you want to do is absolutely make sure they're following the PERA, the Purdue model, with the IT systems in level 4 and 5, that enterprise network business logic, separated by a very well put together DMZ. And then you have your OT systems, operations, control, basic controls, and physical processes separated between the two with a nice DMZ, because you don't want somebody in the IT system area clicking on a link and creating damage in the OT area. When we look at IT systems and we look at IoT systems, we see differences in protocols. And with OT, it's even crazier in terms of the protocols that are around. I mean, if you look over here from BACnet to Omron to Profinet to S7Com, all at the bottom here in level 0, 1. And then we have 6LoWPAN and DMP3 and HART, and all the way up here where we have OPC-UA. Oh, hey, have you ever heard of this one? TCP/IP. So it gets involved now and then. But one of the things, especially when you're dealing with SCADA, for those of you who are actually in the industry, I bet you'll recognize the ISA/IEC 64443. This is used at 0, 1. It's used at level 2 and at level 3. It's used for lots of different devices, controls, etc. So these are some of the protocols you need to be aware of when you're getting into OT. So there are challenges with OT. Some of these are very similar to a lot of the other challenges that we've been talking about throughout the entire class. But some of them are new and they're endemic to OT. So yeah, lack of visibility. When we have layered environments, we'll see this in cloud also. We've already talked about plain text, network complexity. We'll see this in cloud also. But once we have these layers of networks and these big industrial plants, legacy technology is one of the major ones here. I had the opportunity to spend some time in the OT world just a little bit. I don't consider myself an expert in OT, but once you figure out what's going on, you realize why it's easy to hack. So when I was in college, I came back and I was doing my senior year, I was doing work study, and all the IT, I got there too late to claim an IT work study job. And I really didn't want to work in the university cafeteria or something like that. So what I ended up in, very long story and funny story, but I ended up working for the university's HVAC department, heating, venting, ventilation, and air conditioning. So I had an opportunity to put together ventilation systems and insulate pipes and insulate ventilation systems and do plumbing for like water systems and so on, which came in handy after I graduated. And I was working for a company that had an opening, and the opening, the core of it was managing the telco and IT systems of the company. But they also put you in charge of the HVAC systems. And I beat out some of the older employees that had been there because I had HVAC experience, and it came in handy. And this is where I got to go on tour. I joined the IFMA, which is an International Facility Management Association. I got on the board of a local IFMA, and I was able to take tours of some of the airport industrial systems and other industrial systems around town. And I really got a feel for how these things were put together. It's pretty intense, these industrial systems. It's pretty amazing. Another thing that I had the opportunity to do working for other companies is to go and check some of these things. Like go to the far end of a dirt road, and at the end of the dirt road, there's a place that has a little bit of razor wire around the fence so nobody climbs over. There's a small building with some antennas and stuff on the top. You unlock the padlock, you go inside, and you open the door, and dust flows everywhere. No one goes in there except for maybe once a year or more. And you find this dusty equipment just churning away. It's been there for years, been there for decades in some cases, taking measurements, readings, and yeah, again, legacy technology. And so are you going to tell me that there's a seismic sensor that all it's doing is has a little inductor and a small micro PCB with some logic circuit on it? How are you going to put antivirus on that little guy? There's probably no way. Lack of skilled security professionals. Who's running these plants? Do they have security? I tell you what, now it's beginning to be to the point where people like you who go through and learn this stuff and pass their CEH are being hired in places like this more and more, but not always. Rapid pace of change. So we have that legacy. So you go to that dusty building at the end of that dirt road, and you have these sensors that were placed there in the 1990s, and then on a panel somewhere, you have something that was put there last year that interfaces with them. I mean, yeah, so you have all this change that's going on also, along with the outdated legacy systems. Also, it's not planned out. There is a new need for a new business, and so they just interface it with the old business or segregate it from the old business. It's haphazard. And so we have communications that are, a lot of them are analog, and even some of the digital is not very secure. And sometimes it's a kludge. Hey, we can't get this circuit to work. So the engineers talk to each other. You know what? I bet you if we do this, that, and that, we can make it work. And so there's a rogue device. And then we have convergence with IT and with the organizations that are running these and trying to organize it all across multiple production plants. And then we have proprietary software and vulnerable communication protocols. Why are they vulnerable? Because legacy technology, outdated systems, absolutely. Remote management protocols, so people can get to the controls and the UIs, user interfaces, and it's not sufficiently segregated, segmented, and physical security. You know, when I was a kid, don't tell anybody, just keep it between you and me. I used to go and explore some of these plants. So I don't want them to, catch me on a camera from 1980 and then arrest me now. So I used to go and explore some of these places, and because I'm curious, always curious. And so you just act. I figured this out when I was in high school. That act like you know what you're doing, and people give you the benefit of the doubt. So if it looks like you're not supposed to be there, you just act like you are supposed to be there. In fact, you can even address that person, and maybe they're not supposed to be there. Either way, I've explored a lot of these, and they don't have a lot of physical security. I will tell you this, though, it's getting better. And then dependencies on vendors. Oh, and sometimes, in fact, many times, the vendor that supplied an entire section of the stuff they use isn't in business anymore, but they're still running those items because they work. And then we have resource constraints. Those are financial and physical resources. Lack of encryption. Let's go back up here. Here we go. Where is it? Legacy, outdated, right? Lack of encryption. And then data integrity. If you're not encrypting, it's very likely that you're not guaranteeing that the data is getting from point A to point B appropriately. So these are some of the challenges. And then we have vulnerabilities that are related directly to all of these challenges. Sometimes they're publicly accessible. In fact, we'll see how to do that as we get a little bit deeper. And then there are remote connections that you can find your way right through and secure. Missing security updates. It's hard. You have a production plant. And what if, in order to update something, you have to take that section of the plant offline for a certain amount of time? A lot of these plants have extremely sophisticated methodologies for taking them offline. You have to go through hundreds of steps in some cases, and they have to be done appropriately and in time. Then you go into that part of the plant. You have to recognize while you're going into this part of the plant that there are hazards. It could be gas hazards, could be electrical hazards, could be physical hazards. And then you update the elements, and then you double check to make sure the elements are updated. And hopefully you've role played this back in the office, because if you bring everything back online and those elements don't work, you're in big trouble. So then what you do is you take those hundreds of steps and you bring that part of the plant online, and meanwhile you've fallen behind your production goal. I mean, do I really want to run the update if I am going to lose money this year because of it? You have to kind of balance that. Do I want to get hacked? I mean, yeah, this is something that industrial plant managers really have to struggle with sometimes. Weak passwords, it's part of the devices themselves. Insecure firewall configuration. Sometimes with the list of protocols that we're just talking about, we really have to configure the firewall for those protocols. Most firewalls are made for regular LANs, and so you have to do a very good job of configuring the firewall to make that work. OT systems placed within the IT network. Click on a link and they're in the hack. Insufficient security for corporate IT network from OT. That's that Purdue model we're talking about. Lack of segmentation. Again, same thing. Lack of encryption. Unrestricted outbound internet. So there's a lot that can happen with OT vulnerabilities. Very important for us to understand that for two purposes. Number one, to hack it. Number two, to defend it. Because as an ethical hacker, ultimately, we're hacking for network defense. Okay, so MITRE, they've made an attack for ICS. So this is basically the way that most attackers attack ICS. It starts off with initial access. So what they're going to do is they could do some type of drive-by compromise. They can maybe have a public-facing application that helps to exploit remote services. But either way, we're going to get initially in there, and then we're going to execute. So there's some type of malicious code that is executed, maybe gaining access through an API, maybe bringing up a CLI. Persistence, we're going to make sure that we maybe change the firmware, update the execution of our malware through some type of API hack. Privilege escalation to get more access, maybe using a hooking technique like we talked about in one of the previous modules. And then evasion, so that the commands for our remote access are not able to be picked up by the firewall, ICS, IDS, IPS or IDS. Rootkits, things like that get installed on systems. And then there is discovery. So this is where we go through and learn about more of the network, enumerating that network, finding information about the devices on the network, what they control, what systems they are dealing with. Then lateral movement, so where we move, gaining default credentials, maybe doing downloads and getting access to remote services, and then collecting, right? We're going to find information, repositories, automate the collection. Automation is always good. Command and control. So if we're doing an ICS SCADA, if we're doing a OT level attack, then what we're going to want to do is proxy out to our C2 systems and bring in some of the tools that'll help further the attack. And then inhibit the response. So we want to make sure that we don't allow a response to the attack to go through. And then we're going to impair the process controls. So like maybe through IO brute forcing or altering parameters or whatever. So we're taking control of those physical systems and the impact. Check this out. So this is the techniques. We're going to damage, disrupt, gain control of those systems and its environment. And so we damage property, loss of availability, and denial of control. And in an industrial system, this can affect people's lives. So that's why being able to secure these networks is so important. Threats against OT systems. So we have this legacy software, outdated software, maintenance, data leak. And for some of the things that we've been already talking about, a lot of these would seem like they would be a result of that. For instance, if I have lack of encryption and I have interfaces available on the internet, yes, we're going to have data leakage, and we have denial of service attacks. We can take that entire OT network and use it in a botnet. HMI-based attacks, HMI, human machine interface, it has a UI, user interface. And so that means we can hack it similarly to how we would hack regular software. And then we can go back maybe from the OT or from the enterprise and back and use enterprise specific tools and hack them, do spear phishing, malware, maybe finding unpatched vulnerabilities, side channel attacks, buffer overflow, RF. There's just a lot of threats. And we'll see some of the tools and techniques that we use to exploit these. So the first one we're going to talk about is HMI. Like I mentioned just a few moments ago, one of the reasons HMI can be successful is because it is a software interface. So when you look at HMI, it looks like something like this. So let's say that you're in an industrial plant. One of the screens that you might look at that has motion and it shows you the flow of that plant is this one. I got this from Silco Systems. And we have multiple tanks, right, in each of these tanks. We have temperature, flow rate, and level of each of these tanks. We have mixer speed. We can see these impellers. We can see a valve. This valve's at 50%, and so on. So we can watch what's going on with each of these controls. And these interfaces, they're active. They're active. So they're actually moving, and when things change, you can see the change in the interface. So this is a typical larger HMI. There are smaller HMIs, like for instance, you may have some type of butterfly valve, and then you walk by it in the industrial plant, and you stoop down to get this, and you tap on this little HMI, and it shows you the valve position or something like that. So it might be just something as big as a phone that's connected to part of the industrial plant, or it might be a panel like this, and then this panel, you imagine 100 other like this wrapping around. And this is a large industrial plant would have these HMIs. So what can happen, just like with any type of application-based system, you could have memory corruption. Remember, we're talking about heap-based and stack-based buffer overflow in module 6. We could have credential issues where the attacker can abuse hard-coded credentials. That, by the way, that's called a duck attack. Duck attack. The last module of the class, we're going to talk about different cryptographic attacks. And duck means don't use hard-coded credentials, right? So hard-coded passwords. We also have lack of authorization and code injection. All these, I mean, yeah, look at this, ActiveX. Did you program with ActiveX? Have you been around that long? ActiveX is a Microsoft technology, but yeah, some of these industrial systems are still using ActiveX. There are also side channel attacks. Again, a side channel attack is when you're not going directly into the attack of the interface, into the attack of the data or whatever. Instead, you're analyzing the environment, maybe using an oscilloscope or some other type of probe or heat or temperature. Either way, what we're doing is running timing, power, temperature analysis to determine what types of security technologies are being used. Then we have PLCs, programmable logic controllers. And what might a PLC look like if you were in an industrial plant and there was a PLC? Well, I found one for you. I like this one. This is one of the EH150s. This one is often used for training people. It gives you what these things are. So if you look at these, this is the power supply. You wire that in the base unit. And then there are some cables for connecting peripherals. There's I/O controllers, analog input modules. There's a little CPU and memory in some of these modules, or in the back plane. There's a back plane to these. And then you have multiple modules that you can put in. This is a dummy module, output module, input module, counter module, and communications module. So you may have multiple modules. So what you can do, and there are some much larger PLCs, is you can pull out a module and swap out another module with them. They go into these slots here. And with a PLC, what happens is somebody's going to look online, like using Shodan or Census or some type of Google Dork or something like that. What they're going to do is they're going to gain access. And we don't see here how they gain access, but there are many different ways of doing that. And then that's going to maybe by you inject a rootkit, so now you're in control of it. Or maybe you launch a control of flow attack against the runtime. Or maybe you gain access by, hey, you know what? The password is password. Aha, found my way in. This reminds me, I'm going to go off the rails just a little bit here. EC Council has a world hacking contest. And there was one team that used to compete all the time and do extremely well, but this time they were falling behind and the other teams were pulling ahead. They just couldn't get past this interface. They were hacking it over and over and trying all kinds of ways to get past this interface. And finally they're like, let's try this. Admin, username, admin, password. And they got through the interface. And like, oh my goodness. And then they actually caught up and beat everybody else in the end. But yeah, maybe you found out that it is a weak password. And either way, what are the consequences are is, well, first of all, they're going to maybe map IO. We're going to look at this, how you map out and test registers, read-write operations, modify some of the init sequences. Maybe you find the physical processes, read some of that PLC information, pinouts, and so on. And eventually get root access and manipulate the operations. But this is very generic because PLCs are wide-ranging in their capabilities and how they participate in OT controls. All right, so this is one of the attacks against a PLC, programmable logic controller. It's called an evil PLC attack. And so what's going to happen is they're going to find vulnerable PLC devices. How are they going to do this? Well, they're going to scan for it. So in this case, you can see this number one, they're using Shodan to find that vulnerable device. So if it's found, then the attacker turns this nice little, it's just a PLC, very simple device, into an evil. You have to say evil that way for some reason. I'm not sure why, but we'll look that up later. They modify the configuration. They program it, modify its settings and behavior by downloading stuff, and then they can use that to do uploads and attacks of various types. So that's evil PLC. This is another one too. You can use RF, so that's radio frequency or remote controllers, RFRCs. And then what you can do is listen for the signals and just replay them with your remote controller. Or you can do command injection or even pair from the device where it was supposed to be paired. Now it's paired to my device. And we can also do, this is that repairing I was talking about, where we take the, we capture data and then we pair to a part of the operational device and then target that system. And then malicious programming where you can inject malware. There are many different ways of doing this, firmware, malware, etc. We'll talk about some of those as we keep going. Another one that we've seen used to great effect, and to great, I don't mean really, really, really good, I mean huge. So that is supply chain attacks. So we've seen these over and over again. In fact, if you want to, you'll be reminded if you go onto the internet and type in supply chain attack in your search engine and then go to news, and you'll see many of the latest ones out there and some of the bigger ones. So this is a third-party software compromise. You trust that it's going to work. So let's say I have a piece of industrial control software. It's a very powerful piece of software. My company has paid $380,000 for this software. We pay $5,000 a month in maintenance, upkeep, engineers, and so on. We have to trust this company. It's helping us go. And there is a pathway for updates. We get updates through the internet. It's encrypted. it's secure, both ends verify each other, and we trust it. But through that update, that third party sneaks in a hack that affects our entire system, right? That's a supply chain attack. We trusted them. We should be able to trust them. The attackers could alter hardware components during manufacturing so that you get a hardware component or a chipset or a chip that's already open for hacking, or maybe a service provider. So you trust your service provider, but the service provider is through whom the hack occurs. Or maybe there's components that are injected into the manufacturing process, and those components are also going to provide a vector for attack. Or maybe trusted relationships of various types of suppliers, subcontractors, stuff like that, business partners, and they're the ones through whom the attack comes. So these are different ways of supply chain attacks and how they can occur. So another malware. This one's called FoxNet. What is it? It is targeted at industrial control systems. It's destructive, and it's made to disrupt operations, to bring that plant to its knees, modifying data, getting access through gateways, affecting sensors and stuff like that. So this is some of the screenshots from using FoxNet, but there are others too, like Abyss Locker and Industroyer. This one is actually pretty interesting. Pipe Dream and many others. So there is already a lot of malware out there, software malware for ransomware, malware for destroying industrial systems. And be aware that if you have any control of, you work for, or you're part of an OT system, a manufacturer, especially at the state or municipal or federal or country level, you need to make sure that your systems are as tightly locked down as possible, because there are people lying in wait right now to take down your industrial systems. Objective number 5. So what we're going to do now is talk about hacking those industrial systems. What is the methodology that we're going to use? Hey, let's have a look at it. The tool that we focus a lot on the information gathering phase is Shodan. Shodan gives you access to the world of OT and IoT devices, SCADA devices, whatever it is you want to find. You just put in the search parameters. So we see here we're looking for port 502, that's Modbus. And then we're looking for Schneider Electric. We'll see that a little bit later. And in the United States. So you can select your country, select your protocol, select your manufacturer, and bada boom, you have search results from Shodan. And it'll highlight the country location, the number of results, and give you information right over here. Another thing that you could do is go to cert.net. I use this a fair amount of time. What I'll do periodically for some of my, let's say, cheaper small business contracts, they don't want to spend a lot of money. I tell them, well, we're going to need 2 48-port switches. And they're like, can I get the generic one from Walmart? It's like, no, we need something I can actually defend. So what I need is at least a Cisco, whatever. I always tend towards Cisco. And then they'll say, what? It costs that much? I don't know about that. So then we go to eBay and I'll get them one from eBay that costs about 1/10 of the cost, but that means I have more work to do. One time I got a router for one of my clients, and I got it in from eBay, and I was expecting to have to get the default username and password, but instead it had a major manufacturer, and the configuration from that manufacturer was still on the device. I was shocked, and I could have actually saved that configuration, or parsed it to see there was some email in there, but mainly IP addresses and computer names and locations. But instead, I just wiped it out, reloaded it, and programmed it for the organization I was using it for. But yeah, so you can get all the default information from places like cert.net, Search Diggity Dog, and others. All right, let's talk about Nmap. All right, so with Nmap, you take some of those layer 0 and 1 protocols like PCWorks, Omron, Procon OS, Niagara, Botnet, Modbus, Siemens, etc. And there is a script for that. So if you're doing Omron, /script Omron-info. If you're doing a Procon OS, /script Procon OS. And I've had students that wondered about these commands for the exam. And what I always tell them is to use a specific study method for this type of slide. And that's called the Sesame Street method. So back in the days of Sesame Street, we had two protagonists that were often interactive for the audience. Protagonist A would be Bert. Protagonist B would be Ernie. And there was a song they played, which is one of these things is not like the other. And this is what I do when I'm studying for exams. And I ask myself, which one of these things looks different than everything else? That is probably where the question is going to come. So I am not going to get a question like this on the CEH exam. Here's a question I will not get on the CEH exam. So Fred, a network engineer at CEH Corp, has been tasked with information gathering for his ICS SCADA systems. Which Nmap command should he use? Nmap dash lowercase s, uppercase s, dash capital F, and then the IP address. Nmap, and it gives you all these, and he's tasked with gathering information about an Omron system. I forgot, I left that out, an Omron system. The answer would have the name Omron in it. That's too easy. I don't want to make an easy CH test. No, I don't want to. I don't want to make the answer and the question match. So I don't want to say that this guy's looking for Modbus systems, and here, look at it, Modbus-discovered. No, what I'm going to do is I'm going to do one of these things is not like the other. So I may say something like, for instance, that Fred is scanning HMI systems. And then I might have an answer that says /script HMI-protocol or something like that. It's like, is that the one? No, that's not. There is no script like that. In fact, for HMI, it's a PNST-P. The port is 46824. So that one is kind of not like the other. And of course, this one here, well, you see the scan delay and max parallelism and so on. This is made to be very, very, very gentle on an OT system because you can DDoS an OT system with an Nmap command or DOS the system, denial of service. Is worse than an attacker. And this one too, I think this is a little bit confusing because of people who deal with networking. When I say ENET over IP, you know what I actually think? My brain swaps it around. And my brain says IP over Ethernet. I do that all the time, every day. That's how I live. But no, it's ENET over IP. And so that is actually an ICS SCADA protocol. And so look out for that one too. So number 6, number 2, and number 1 are probably you're more likely to hear from on the exam. But hey, be prepared for any one of them to show up on the exam. Fred might be using Omron. All right, so what else can we do? We can analyze traffic using Wireshark. Here in Wireshark, we're taking our frames here and we are filtering for Modbus, and now we can get our Modbus information or whatever the protocol we're looking for. We can do that. We can also use Malcolm, which is a powerful network analysis tool, and helps you go find all your items. It gives you a nice distribution of the different types of protocols and items that you have, and so it's very, very good for getting a lot of those that system. Other things that we have is good old Nessus. Yeah, you can run Nessus. You go over to the policies, create a new policy, new network scan, new discovery, give it a port range, And that way we can run a SCADA scan using Nessus. Nessus is very cool that way. Skybox is also very nice. Allows you to not only scan that network, but look for attack vectors. Smart RF Packet, Microsoft Defender for IoT. Yeah, they have Defender for IoT at Microsoft. We also have fuzzing. Fuzzing we use to mainly focus on that firmware. But either way, Modbus, BACnet, IPP, gathering that information. You can use things like Fuzzwosky, good old Fuzzwosky. So this is the Fuzzwosky commands. It's just some of them that you can use to fuzz test those devices. And I want to pause here for a moment and talk about what you need to do to hack this area of technology. So one of these is pretty easy. We've talked about a few of these already when we were in module 7 and talking about setting up an environment to reverse engineer or to get IOCs from binaries. And so we use stuff like binwalk. And I think we talked about IDA Pro. There are a few of these. And then in module 6, we use the immunity debugger. So these are some of the software tools that we can use to reverse engineer the software that is on OT and IoT and software in general. So these are very good. We've talked about these. What I want to focus on is the hardware tools. One of the things I said earlier, it is important that you have a little bit of hardware facility, that you understand how to use breadboards. You understand what a printed circuit board is. If you open up a case, that you can identify some of the components and understand a little bit about the electronics. So being able to use a signal analyzer is pretty good. But you must, and I'm saying this from my own vantage point, I would like you to be able to use the following items. A multimeter. If you've never used a multimeter, it's not too difficult, and you should learn how to use a multimeter. Is it going to be on the exam? No, I'm talking real life here. You should also be able to use an oscilloscope, right? Can you get your CEH without using an oscilloscope? Of course. I mean, it's not even in the practical, but it's practical for real life to be able to use an oscilloscope. You should be able to use soldering equipment to be able to solder in a little circuit and desolder it and have a little solder workstation, etc. Now, most of you probably know how to use a magnifying glass. Well, there's that one guy. Okay, but most of you know how to do that. But also communications interfaces. So like the GPIO on a small single board computer, or some of the pins on other PCBs, you should know how to interface a little bit with those. You don't even have to be good at it. And then, of course, screwdrivers. Well, there might be one or two of you that have never used a screwdriver. Yeah, you maybe had a screwdriver at the bar. That's a different type of screwdriver, right? This is one flathead or having their Torx screwdriver or whatever. And then tweezers, obviously, etc. But these are the three that I would recommend that you get some knowledge with. And if you can, this is actually very wonderful to know too. Memory programmer microcontrollers. So what you can get is these specialized microcontroller chips, and you can get a kit that teaches you how to do essentially machine level programming on these chips, so you understand how the microcontroller works. You understand at an extremely low level how this is processed. I remember at the beginning, like I think it was freshman or maybe sophomore year, in digital logic circuits in my EE studies, that's where we started, and then you move into greater things from there. But that would be good to have. But the rest of these, multimeter, oscilloscope, solder equipment. Last point about that is there was a time when if you wanted to buy an oscilloscope, you had to drop a couple grand, $2,000, $3,000. Now you can get a multimeter oscilloscope combination on Amazon for about $100. So it's insane how cheap they are, and you can learn on it and learn to use it. You can get a soldering station from anywhere from $10 to $20. $50 you'll do fairly well. and then you can get projects that will help you learn to use these. One of these things I had meant to mention when we were talking about wireless, and that was the idea of a directional antenna. There's a project that you can find online called a cantenna, or a Pringles cantenna. And you get a Pringles can, or either that or some type of tubular can that's made out of metal or coated with metal. And then you can buy a kit that you put together and create a extended unidirectional Wi-Fi signal. So learning to build things like these, using soldering equipment, using an oscilloscope, a multimeter, these are good skills that I would like for you to learn. All right, now, just like usual, on almost every module, this little baby universe comes to play. That is Metasploit. And in this case, we are using Metasploit to spy on and hack Modbus masters and slaves. So mainly we're going to be attacking the slaves, but communicate in plain text without any authorization. And so what we do here is we start off, they're just running through a show options here, but anyway, we set our host, and over here we set our data address and set and the number. We hit run, and over here what it's doing is it's sending read registers. This is very important for what's going to happen next. But in order to understand what's going to happen next, we have to have a look at some stuff here. So first, there was Modicon. Modicon was very good at setting up ability to use Modbus masters, slaves, etc. Modicon was really, really good at that. Now, the problem, and this is not a problem, but the thing that happened was Schneider Electric bought Modicon. So now we have two sets of addresses that you'll see. They give you the parameter and the data size, etc. We can use Shodan to find these. But either way, let's go back over here. What we're going to do is we're going to install the Modbus-CLI, and then we're going to get it all up and running based upon those data types. When we find one online, then we can run the hack. So here's how it starts over here on the left. On step number 4, what we're going to do is we're going to test. In fact, you'll see step number 4 and step number 6. They're all about testing to see if we can do it or not. So in this case, what I'm going to do is I'm going to do Modbus read. Give it the IP address. Let's go back to the previous slide. The IP address that I discovered in Shodan, or wherever it is I'm scanning. And then I'm going to give it, you see both the Schneider and the Modicon addresses, because maybe it's using Schneider, maybe it's using Modicon, maybe it'll respond to both. In this case, it responds to both. And so turns out it worked. You can see that's the Schneider. Yeah, so yeah, it's a Schneider address. They always have percents in front of them. And then we go down here to step number 5, manipulating the value. And now we're like, can I change the values in the coils of this device? And so I do a write to the target address, and I try to change the values in those coils. And sure enough, it says, okay, good. Well, now I know I can read and write those. Now I'm going to read coil values and manipulate coil values. So I said coils over those are registers. These are all registers over here. And these are all coil values right down here in step number 7. So I've proven that I can get access to this Modbus slave information. So now what I want to do is track it, make sure I don't forget it. So now what I'm going to do is I'm going to do that Modbus read, and I'm going to output it to a text file and give it the same information and coil values also. So now I've kept track of my Modbus hack, and now I can go back and use those values for other purposes. There's another nice little protocol called DMP3, and a lot of industrial systems make use of DMP3, and they're configured with that direct internet access. And so using Shodan, we might be able to find out that, yeah, port 20,000 is open, and so we can get into DMP3 and gain access through DMP3. So there are a lot of OT attacks of various types, and so now we're in objective number 6. And here in objective number 6, we're going to look at some countermeasures. Let's go. So for OT, it can be difficult because of the mixture of legacy and old equipment with new, and old protocols with new, and so on. So what we want to do is we want to use purpose-built sensors. So what we're going to do is purposely check the entire network to look for vulnerabilities. We're going to patch and update. We're going to use, for any type of application, secure coding practices. We're going to track our asset registers, use strong password VPNs. So that's a ubiquitous IAM on that strong password, and ubiquitous encryption using that VPN, securing that perimeter. And then we need to have a anti-malware tool that can allow us to scan not just the internal business network, but we also want to be able to reach at least a little bit into the OT network and disable any unused services, patch it, make sure you have an IDS. It needs to be an IDS that will work in an industrial context, and be very careful with working with third-party products, making sure you're running good cryptographic signatures, and auditing all the time, looking for changes in data flow. I would also suggest that your network and OT defenses make use of tools that will allow you to plug in some type of AI module. A lot of the enterprise tools will allow that. And then you could use your own OT network as your data for deep learning and find protections, loopholes, find vulnerabilities, and stop those vulnerabilities from becoming attacks. So what are those vulnerabilities? Publicly accessible, insecure. There are a lot of them. Let me see if there's any of these that we haven't really talked about a lot. OT systems placed within the corporate network. Don't do any of that. So separate those out, right? We talked about the Purdue model. Let's see where there's lack of segmentation. Also, oh yeah, you don't just segment the business network from the industrial network. You also need to create small segments in the industrial network, because if one of those segments gets attacked, it's less likely they'll be able to pivot to another segment. Of course, lack of encryption, unrestricted internet access. So there are a lot of those. If you want to secure that, what we want to do is follow that Purdue model. What we want to do is have a nice enterprise separation from the industrial. So we have a DMZ we're hoping that we can take care of these risks like malware injections, network infections, etc. So we're going to use controls like IDSs, anti-bot, etc. In that DMZ. And then on the manufacturing side, to try to avoid things like ransomware, bots, DDoS, unencrypted credentials, and physical security issues, we're going to use IDS, IPS sandboxing, traffic encryption, firewall communications, authorized RTU and PLC commands, and then do not authorize the rest. And then, of course, you want to secure at the physical layer and secure that gateway. This is difficult. I always joke with my students. We talk, and I think I said this to you too, but when we talk about IPv6, like, yeah, why don't you go ahead and implement it? We talk about zero trust. Yeah, well, maybe after class. I mean, we have a few hours after class. Why don't you go implement zero trust? If you knew anything about how difficult it is to implement zero trust network wide and still have a robust network, you can see you would know it's very difficult. It is. And so for zero trust for ICS, that is where you want to head. So you define the network, map the traffic, manage it, architect it. You have to sort of redesign. you may have to spend a lot of money on that re-architecting, and then you develop that ZT policy, implement the ZT policy, and then from there, you don't trust, you're zero trust. There's no trust here. We monitor it very carefully to make sure someone hasn't found a way to hack that zero trust network. So with OT, if you are tasked with pen testing OT, you are tasked with defending the industrial plant. You need to develop policies and procedures that have never been run at this plant. You're not alone because you have the OTCC, you have the OT ISACA, NERC, and others that can give you the guidance that you need to get this stuff running. So these are some of the best practices for collaborative information sharing among people who are running industrial plants, running OT, and they can help guide you where you need to go to make sure that your organization is defended from OT attacks. There we go. So as you can see, IoT and OT are no big deal. Actually, they are a very strong target of attacks, and they are a big deal, and we want to make sure and defend them. We've seen many ways of hacking IoT and OT. Scanning, one of the main tools being Shodan, maybe Census, even Nmap once you get closer to the network. And we've seen some of the protocols that proliferate through IoT and OT environments, and some of the low-hanging fruit, especially in OT environments, that allows nation states and threat groups to threaten and attack OT infrastructure. So it behooves you to make sure that if you're on the pen test side, that you take a good deep look at OT. Also, remember all the stuff I said regarding the exam, and we have some labs that we're going to do. Not as many as some of the other modules, but we have some. So let's do those, and then we'll head into our cloud module. See you there.